Hello everyone, this is Avinash, Assistant Professor, Department of Pharmaceutical Chemistry. So today I'm going to share another video on synthesis of neostigmine. Right. So, neostigmine is an example of indirect acting cholinergic drug, or you can say it is an colon esterase inhibitor. So I think most of the people or students are aware about this colon esterase inhibitors. So, colon esterase inhibitors are the chemicals that prevent the breakdown of the neurotransmitter acetylcholine. This increases the amount of acetylcholine in the neuronal junction that can bind with muscarinic receptors or nicotinic receptors to show its biological activity. So if I want to explain in a simple way, this colon esterase enzyme is very important. Okay, so acetylcholine is a very important neurotransmitter. So this acetylcholine, when it reacts with colon esterase enzyme, okay, it will degrade into choline and acetate ions. So these choline and acetate do not have the biological activity. Okay, there will be complete loss of this neurotransmitter action. So at the junction of neuronal receptors, this acetylcholine concentration can be decreased and you may not observe this biological activity which can be shown by acetylcholine. So your colon esterase inhibitors are going to stop the degradation of acetylcholine. Therefore, what happens? This acetylcholine concentration will be increased at the neuronal junction. Therefore, this acetylcholine can bind with muscarinic or nicotinic receptors to show its biological activity. Okay. So generally, this drug neostigmine is used as, or you can say neostigmine can be used in the treatment of myasthenia gravis. Myasthenia gravis is a neuromuscular disease that leads to skeletal muscle weakness. So most commonly affected muscles will be your eyes, face, and this can also result in double vision, drooping eyelids. Okay, so drooping eyelids is one of the characteristic feature of this myasthenia gravis, followed by the persons will have a lot of trouble or difficulty in talking and walking also. Okay, and at the same time, this neostigmine can also be used in the treatment of urinary retention problems. Okay, so there are two important indications of neostigmine. One is this drug can be used in the treatment of myasthenia gravis. Second thing, it can be used in the treatment of urinary retention problems. Okay, Now we will directly switch over to the important aspect, that is synthesis of neostigmine. So I will try to erase all this. So usually the synthesis starts from a starting material called as potassium N, N dimethylamine phenolate. Okay, so I'll write the structure of this starting material so we can understand the synthesis of neostigmine. Potassium N, N dimethylamine phenolate. This I'm going to react with this is dimethyl carbamoyl chloride. Now, you listen this synthesis very carefully, okay? So initially what happens is this potassium N, N dimethyl amine phenolate reacts with dimethyl carbamoyl chloride. So what happens here is, so if you compare the electronegativity between oxygen and potassium, definitely potassium will have least electronegativity. So you can designate by a positive charge. Okay, so when potassium gets positive charge, the adjacent oxygen will get negative charge with 3 lone pair of electrons. Why? Because as oxygen is more electronegative, it has a tendency to attract the electrons from this particular bond which is present between oxygen and potassium. Therefore, oxygen will get 3 lone pair of electrons with a negative charge, right? Now, look at the structure of dimethyl carbamoyl chloride. So, you compare the electronegativity between carbon and chlorine. You know, chlorine is a halogen, and most of the halogens will have very good electronegativity profile, and halogens are considered to be good leaving groups. You might have studied in your pharmaceutical organic chemistry about this leaving groups. So halogens are very good leaving groups. They can leave the reaction by breaking the bond due to the electronegativity difference between the two atoms. Now, if I break the bond here between carbon and chlorine, what happens? The sigma electrons which are present in this bond will migrate towards chlorine. Therefore, chlorine gets negative charge and this hydrogen will get a positive charge. Okay, now what is the problem with this carbon here? It is electron deficient. It requires electrons. So as oxygen is having one extra lone pair of electron, so this oxygen will donate one lone pair of electron for this carbon. Therefore, what happens? There will be a new bond formation between this oxygen and carbon. At the same time, this positively charged potassium and negatively charged Cl minus, okay, K plus and Cl minus reacts to form potassium chloride. So this potassium chloride is liberated as a byproduct in the synthesis of neostigmine. So if you remove this potassium and chlorine, so there is a chance for oxygen to donate its lone pair of electron for carbon to form a new sigma bond. Now you can write this intermediate compound. So you can write the same benzene ring, what you got in the starting structure, unsaturation, that is, and NCH3 taken twice. So usually nitrogen will have one lone pair of electron always. Okay. So at the same time, what is another point you have to take here? Oxygen, the same oxygen I'm writing here. Now oxygen gets only two lone pair of electrons because this extra lone pair, it has already donated to carbon. So this oxygen will form a new bond. So this is a new bond which is going to form between oxygen and carbon. So you can write the same here, okay, followed by this one, nitrogen with two methyl groups. You can write NCH3 taken twice, or you can write in this way also. There is no issue. Okay, so this is neostigmine. Okay, so if you want to prepare neostigmine bromide, so if you want to prepare the drug in the salt form, okay, you can react this neostigmine with methyl bromide, CH3Br. Now again, bromine is a halogen, so it is a very good leaving group. It can leave the reaction with a negative charge, so the adjacent methyl group will get positive. Okay. So what happens here? As nitrogen is having one lone pair of electron, right? So this lone pair of electron, it will donate for carbon. So what happens? This nitrogen will pick this methyl group and it will add here. Instead of NCH3 taken twice, you will get NCH3 taken thrice. Okay, now you can write this structure once again. Here you will get nitrogen, but nitrogen will get electron deficiency. Why? Because nitrogen has donated its own lone pair of electrons for the methyl group. Okay, so here in brackets you can write CH3 taken thrice. Okay, because this methyl group also adds here. So instead of 2, you can write 3 methyl groups, followed by same OC double bond O NCH3 taken twice. The same I have written here. Okay, so this is the structure for your neostigmine bromide. Okay, so in the examination, if they ask you to write the synthesis of neostigmine, you can stop up to here. If they ask you to write the synthesis of neostigmine bromide, just you can react this neostigmine with methyl bromide. Okay, so as nitrogen is having one lone pair of electron, it will donate for this methyl group. So you will get one extra methyl group here to form NCH3 taken thrice, and nitrogen will get a positive charge. Okay, and this bromine will be added towards your neostigmine to form neostigmine bromide. Okay, so this is about your synthesis of neostigmine and important therapeutic indications of neostigmine. Thank you very much. In my next video, I'll upload few more important synthetic drugs to be explained. Okay, thank you once again.